What's up, guys? We are going to do homework number 134, which is this questions. What is the force F on the 1.0 nanocoulomb charge in P25.34? Find out the magnitude and the directions, which is sorry, that's the diagram. And those are known conditions Q1, Q2, Q3, and K, which is with a convergence. Q1 equal to 1.0 nanocoulomb converted to the coulomb is time to the negative 9, 10 to the negative 9. Same as those. We know the K, 9.0 times the 10 to the positive 9 Newton meter square per coulomb. And we're going to use those equations to solve this problem. Let's start it. So here, see, I draw a giant free body diagram. It's a little messy, but we can still do it. So we know two positive charges repel each other, and positive and the negative charge they attract each other. So in here, the key to solve this problem is to looking for this F9. How do we find out? Easy, because the force is a superstition. So it turns out we gotta draw those two vectors first, positive, positive. It turns out this is F1, F2 onto 1, and same here. They are attractive. So it turns out this is F3 onto the 1 vector, and you just turns out you draw like this, you will get the F9, the force, the net force. The net force. But since we identify the directions to the right, we should consider this as a component. So F9 is on the x axis. So how those two forces contribute to the F9x? So I draw here. F2 to the 1x plus F3 to 1x, they are on the same direction. So that's why they contribute to this line. And how do we find out this? Is you see there's an angle which is 60 degree. How this is 60 degree? Because component F2 to the 1x is parallel to this line, and then this here is 60 degree, and so on, so same as here because they are parallel. So same here, this triangle is, the angle here is also 60 degree, and here because this component F3 onto the 1x is parallel to this line, so it turns out this is 60, this is also 60, and then we are going to use triangular problem to solve like everything. So back here, I wrote this everything's already because I'm the whatever, it's just a reason. So how do we find out the net force for x component, which is here where I'm wrote, is actually using we need to know the force between the F2 to the 1 first, and times to its the angle, which is cosine 60, and we got 8.99 times 10 to the negative 5 newtons. And same as here, 3 to the 1 is they are just attracting each other but with the same volume. So it turns out this is 8.99 times 10 to the negative 5 newton x component. And F9, you just time them together, time 2, because they are the same. You got 1.798 times 10 to the negative 4 newton, which is directed to the right. And that's all for now. If you have any questions, you can give me comments.